In this lecture, we are going to discuss about another example for predictive parsing table. Predictive parsing table is a kind of top-down parsing method. So it builds the parse tree from top to bottom. So this is the grammar we are going to consider. Okay, so we know that the first step is elimination of left recursion. So the grammar is called left recursive grammar if the symbol on the left side is equivalent to um, right side, first symbol on the right side. Okay, so here the symbol is yes, but here the first production starts with left parenthesis and the second production is a. So this is not a left recursive production, but if you consider the second production, here the symbol on the left side is L and first symbol on the first production is also L. Okay, both are L. So this is left recursive production. Okay, so we need to eliminate left recursion. So if the grammar is not a left recursive grammar, directly we can go with the second step, that is left factoring. Okay, but this grammar is left recursive grammar, so we have to eliminate left recursion from this grammar first. Okay, so for that, first we know that the first yes production is not a left recursive production, so that we can write as it is. So yes tends to open parenthesis L close parenthesis and A. Then to eliminate left recursion from the grammar, first we have to write the symbol L, symbol on the left side of the production L tends to consider all non-left recursive productions. So here we have only one non-left recursive production, right? Because this production starts with another symbol. Yes, it doesn't start with L. So this is the non-left recursive production. So we have to write all the non-left recursive productions. So here we have only one non-left recursive production. Okay, then we need to introduce a new non-terminal symbol. For example, here we have considered L prime, or we can call it as L dash. Then this new symbol implies L dash tends to, or L dash gives, from the left recursive production, from all the left recursive production, we have to write all the symbols except the first symbol. Okay, so here comma and yes, comma and yes. Then we have to rewrite the same new symbol, so L dash. Then bar epsilon. Okay, so this is a way to eliminate left recursion from the grammar. So first we have to write L tends to, write the non-left recursive production yes, introduce a new non-terminal symbol L dash. Suppose if we have T here, then we need to write T dash. B means B dash. Likewise, we need to introduce. Okay, otherwise we can write another non-terminal also, like X, Y, Z, anything. Okay, then we have to write the same non-terminal L dash tends to. From the left recursive production, write all symbols except the first symbol. So here, comma, yes, then rewrite this L dash, then vertical bar, epsilon. Okay, then second step is left factoring. Okay, so left factoring means we have to check the right side of all the productions. If if two or more productions are starting with the same symbols means, then we need to do the left factoring. Otherwise, we cannot. No need to do. Okay, so first in the S production, first production start with open parenthesis or left parenthesis. Second production is A. Okay, there is no common symbol. Common symbol means from the left end we have to check the common symbol. So here open parenthesis, here A. And this production has only one production. So no need to check anything. Here comma and epsilon. Okay, so the first step is over. Second step is also no need to do, because there is no common symbols. Okay, so no need to do left factoring. Now we need to do the first and follow function. So here, first of yes, first of all non-terminals should be found. So first of yes, okay, and there are three rules for first. First of any terminal symbol is terminal symbol. First of, suppose if we are finding x tends to epsilon, and first of x means uh, epsilon. Okay. First of terminal symbol is a first rule. Second rule is if x tends to epsilon is a production, then first of x is epsilon. Suppose if x tends to y1, y2, uh, up to yk, k number of symbols on the right side, means first of x is first of y1. Okay. So but suppose if y1 contains epsilon, then we need to find first of y2 also. Okay. Please refer first and follow function video. Okay. So first of y1 is suppose first of y1 contains some three symbols along with epsilon, means that three symbols we have to add. Then for epsilon we need to find first of y2. Suppose first of y2 also contains epsilon, we have to add first of y3 and so on. Suppose all k symbols are having uh, first of all k symbols are having epsilon, means then epsilon must be added to first of x. Okay, these are the three rules. Okay, so first we need to find first of s. First of s means there are two productions. So actually here we need to find s tends to some k number of symbols. So the third rule. Okay, so first of s is first of left parenthesis. Since left parenthesis is a terminal, first of terminal is terminal. Okay. So first of s is open parenthesis or left parenthesis. And as per this second production, first of s is first of a. Since a is also a terminal symbol, first of terminal is terminal. So that's all. Okay, left parenthesis and a. Then uh, first of L. First of L means first of S. Okay. So first of S we already found. It's open parenthesis and A. Then first of L dash. First of L dash is first of comma. Comma is also a terminal symbol. So first of comma is comma. Then epsilon. Okay. Since x tends to epsilon means first of x is epsilon, right? So similarly, L dash tends to epsilon is a production. So first of L dash is epsilon also. Now we need to find follow function. Okay, so follow of yes, L dash we need to find. So here also there are three rules. S is the start symbol of the grammar, then follow of S will be dollar. Okay, this is the first rule. Second rule is, suppose if we have a production like A tends to alpha, B, beta, then follow of B means first of beta. Actually, beta is a Greek letter used for representing a string. So, beta may contain any number of symbols. So, follow of B is first of beta except epsilon. Okay, suppose the beta contains epsilon, means then follow of B will be follow of A also. Okay, so first we have to find follow of B is equal to first of beta. We have to add all symbols of first of beta. Suppose if it contains epsilon, then we need to find follow of A also. Then suppose the third rule is, suppose we have a production uh, A tends to alpha B. Alpha also represents any string. Okay, it may contain mixed of terminals and non-terminals. So here also, if you want to find follow of B, here B is followed by nothing, right? So follow of B. So since S is a start symbol of the grammar, we have to add dollar first. Then we need to check the right hand side of the productions. Okay, here there are two cases. In two cases we have yes. So first consider the first one. Here yes is followed by L dash, right? So as per the second rule, follow of yes will be first of L dash. So what is first of L dash? comma and epsilon. So we need to write comma, and then we should not write epsilon in follow of the non-terminals. Okay, so suppose we have uh, epsilon in the first of any symbol, means we need to find follow of that L. Okay, follow of left hand side of the symbol. Okay, so we are finding follow of S. So first we have added dollar as per the first rule. Then first of L dash, since S is followed by L dash, first of L dash is comma and epsilon. So we need to add comma, then instead of epsilon, if epsilon is there, we need to write follow of L also. So we have to find follow of L here, then we need to substitute it. Okay, so as of now we can write follow of L here. Okay, follow of L. So first we have to find follow of L here, then we can substitute it. Okay, so what is follow of L? Follow of L means L is followed by only one symbol. Okay, L is followed by a terminal symbol. So first of right parenthesis is right parenthesis. Okay, so we can substitute it here. Okay, so dollar, comma, and follow of L is right parenthesis. Okay, and one more case we have follow of S. One more case we have. So follow of S is first of L dash. So first of L dash now again we need to add comma, but comma is already added. Then instead of epsilon we need to write follow of L dash. Okay, so we have to find follow of L dash and then substitute it here. What is follow of L dash? Here L dash appears in two cases. So follow of L dash means here L dash is followed by nothing. So follow of L dash is follow of L as per rule 3. Okay, follow of L is right parenthesis. So substitute right parenthesis here, and in this case follow of L dash is nothing. So we have to find follow of L dash. So for follow of L dash again we need to substitute follow of L dash. It doesn't make any sense, right? So close bracket we have already added. So that's all. Okay, so we found first and follow function. Now we need to construct the predictive parsing table. So predictive parsing table, here all rows correspond to the non-terminals. So non-terminals are S, L and L dash. Column wise we need to write all the terminals. So in this example grammar, left parenthesis, right parenthesis, A, comma and dollar. Okay, including dollar we have to write. So left parenthesis, right parenthesis, A, comma, dollar. Okay, then we need to fill this table. So how can we fill this table? Here there are two conditions. Suppose if we have a production like A tends to alpha, then we need to consider the row A. Okay, row A, and column should be first of alpha. Okay, in row A and column first of alpha, we need to write this production. Okay, so suppose if it contains epsilon, first of alpha contains epsilon, we need to write it in follow of A. Okay, these are the two rules. So first we have to consider the production one by one. So S tends to open parenthesis, L close parenthesis. So first of open parenthesis, right? So first of left parenthesis is left parenthesis since it is a terminal symbol. So in row S and column left parenthesis, we have to write S tends to open L close. Okay, this production. Then we need to consider S tends to A. So first of A is A. Okay, so in S row, A column, S row, A column, we have to write S tends to A production. Okay, similarly, we have to fill all. So now consider L tends to SL dash. So here, first symbol is S. Okay, so first of S means open parenthesis and A. So in L and open parenthesis and L and A. Okay, in L open parenthesis and L A, we have to write this production. L tends to SL dash. So L tends to SL dash. Here also we need to write the same. L tends to SL dash. Okay. Then we need to consider the next production. So L dash tends to comma SL dash. First of comma is comma. Okay. So in L dash and comma, we need to write that production. So L dash tends to comma L dash. Okay. Then epsilon. L dash tends to epsilon. So first of epsilon is epsilon, right? So if it contains epsilon, we need to find follow of L dash. What is follow of L dash? Right parenthesis. So in L dash and right parenthesis, we have to write L dash tends to epsilon production. Okay. So that's all about predictive parsing table. Now we can consider one example string and we can parse it. Okay. Okay. So we can consider the input uh, input string open parenthesis a comma a close parenthesis. Okay. So to parse the string, we need to consider the three columns stack input output. So in stack, we have to first write dollar and start symbol of this grammar. Okay. For this grammar, start symbol is yes. Okay, in input buffer, we have to write the input string to be parsed followed by dollar. Okay, so here dollar represents bottom of the stack. Then we have to write yes. Okay, the meaning is we are pushing start symbol of the grammar on the stack. Okay, then input buffer contains input string to be passed dollar. Okay, and here again there are two cases. If the symbol on the top of the stack is non-terminal, we have to refer the table. Okay, so here the top of the stack is yes and the current input symbol is left parenthesis. So we have to refer yes and left parenthesis. Okay. Suppose the symbol on top of the stack is terminal, means it should be matched with the current input symbol. Okay. And we need to pop both. Okay. So first the symbol on top of the stack is yes. Okay. And the current input symbol is open parenthesis. So we are getting this S tends to open, L close. That we have to write it in the output. Okay, in the next line. So S tends to open parenthesis, L close parenthesis. Okay, then here we need to write dollar. And the meaning is this left side of the production is replaced by right hand side of the production. Okay, so S must be replaced by right side of the production but in reverse order. Okay, so right parenthesis L left parenthesis. Here there is no change in input. Okay, so a comma open parenthesis a comma a close parenthesis dollar. Now open parenthesis and open parenthesis. Okay, here top of the stack is left parenthesis, current input symbol is also left parenthesis. So pop the stack. Okay, pop the stack means open parenthesis is removed from the stack and advance the input pointer to the next input symbol. Meaning is we are removing open parenthesis also from the input buffer. Okay. So this is the remaining input string. Okay. Now we need to refer L comma A. Okay. L and A. So we have to refer the table, predictive parsing table. L comma A is L tends to SL dash. So that we need to write it in the output. L tends to SL dash. So here dollar right parenthesis instead of L, remove L and um, write L dash and S. Okay, in reverse order. So L dash S. Here no change in input. Okay, whenever uh, we are having a non-terminal on this top of the stack, no need to remove anything from the input. Okay, no change. Then S and A. So refer the table. S and A is S tends to A. So S tends to A must be written in the output and remove S from the stack and push A. Okay. Then here no change. Then current input symbol is top of the stack is A and current input is also A. So remove both and write dollar left right parenthesis L dash. Remove A here and here also. Okay, now L dash and comma. So since L dash is a non-terminal, we have to refer the table. L dash and comma is L dash tends to comma yes L dash. So L dash tends to comma yes L dash. So replace L dash with L dash yes comma. So L dash yes comma. Here comma A right parenthesis dollar. Then comma and comma matched, so we can remove both. Now S and A. So refer the table. S tends to A is a production. So in the next line, replace top of the stack S with A. Here A right parenthesis dollar. Then A and A both are matched, so remove. Then dollar L dash. Here right parenthesis dollar. So now L dash and right parenthesis. So L dash and right parenthesis is L dash tends to epsilon. So L dash tends to epsilon. So here L dash must be replaced by epsilon. So no need to write anything, just leave it. Then right parenthesis and right parenthesis matched. So remove both. Now dollar and dollar. Okay. So if we have got dollar on the stack and the current input is also dollar, the meaning is stack is empty, input string is fully parsed. Means we can say that the input string is accepted by our predictive parsing table. Okay. So the input string open parenthesis A comma A is parsed successfully. Okay. We need to write like that. The meaning is the top down parsing is constructed. Okay, top down parsing is constructed by checking this output. Okay, so how the start symbol of the grammar is yes. Then it has three symbols. So the children is open parenthesis L close parenthesis. Then L is replaced by SL dash. SL dash. Then S is replaced by A. Then L dash is expanded with comma SL dash. Comma S L dash. Then S is expanded with A. Then L dash is expanded with epsilon. So now if you concatenate the leaves from the left end, you can get open parenthesis A, comma A, epsilon we can leave it, then close parenthesis. So we have parsed this input string, right? Thank you.